Welcome to all. My name is Ms.V.DHIVYA. I am assistant professor in AIDS department and from SA Engineering College. Today my topic is shortest path algorithm. This first introduction. In shortest path algorithm, we all know that what is the Dijkstra algorithm, which is nothing but we are going to find the shortest path in such vertices through the nodes. And the introduction is Dijkstra algorithm is shortest path between the nodes in the vertex. Who founded this algorithm was, it is a computer scientist Edgar W. Dijkstra in 1956, and later on he developed the concept over through the shortest path algorithm. And the algorithm characteristics belongs to which the Dijkstra algorithm can work on both directed and undirected graph, as algorithm is designed to work in any type of the graph, which means it can work in over the directed graph or else in undirected graph, as it meets the requirements for non-negative edge weights and being connected. It is nothing but non-negative numbers also comes under the Dijkstra algorithm. In directed graph, each edge has a direction indicating the direction. We can see the example in upcoming graph. In directed graph, each direction has indicating the direction of the travel between the vertices connected by the edge, which means that if we are going to travel, it will have the vertex 0 to 1. It means that it will have the weighted graph. If the graph tends to 0 to 1 or 0 to 2, we are going to find the shortest path which is suitable for us. In this case, algorithm follows the direction of the edges when searching for the shortest path. If it is an indirect graph, the edges has no direction and algorithm can traverse both directed and backward and forward, which means directed and undirected along the edges when searching for the shortest graph. It is nothing but in undirected graph, it doesn't have any direction which can traverse both direction frontward and backward along the edges while searching for the shortest path. Then this is the working of the Dijkstra's algorithm, which is the first make the source node with the current destination of 0 and the rest with infinity. Then next select the non-visited node with the smallest current distance as the current node. For each neighbor n of the current node adds the current distance of the adjacent node with the weighted of the edges connecting to 0 to 1. As I told already, from 0 to 1 we have a certain distance which will be taken as the shortest path. From it's varying from nodes to vertices where we can take the shortest path. If it is similar than the current distance of the node, set it as the new current distance of the n. Make the current node 1 as visitor. First, which node we are going to visiting will be marking as the current node. And go to the step 2. If there are any nodes are unvisited, what steps we have involved in step 1, then that will be repeated in step 2 and for on. How the Dijkstra algorithm works means, this algorithm finds the path with lowest cost between the vertices and every other vertex. For example, if the vertex of the graph represents cities and edge path cost represents driving distance between pairs of the cities connected by the direct road, the Dijkstra algorithm can be used to shortest route between one city and all other cities. This example tells about the cities and the edge path cost, where the driving distance of the cities connected by the directed road that can be taken as the shortest path and all other cities are connected. This is the example for the Dijkstra algorithm, where it has the node vertices where 0 travels to 2 and 1, 2 travels to 3 and 1 travels to 3, where 3 travels to next 4, 5 and 6. These are the weighted graphs. This graph is called weighted graphs, where the nodes and vertices are connected with the weighted values. Let's see with example. Based on that example, this algorithm will generate the shortest path from node 0 to all the other nodes in the graph. Then we can see the shortest path from node 0 to 1, 0 to 2, 0 to 1, 0 to 2, 0 to 3, and from 0 to 4, 0 to 4, 0 to 6, because these are connected graph with the values. So this is called as a directed graph. Step 1. Now we are going to solve the example. In step 1, we are going to start with 0 and mark node as visited node, and you can check below the image visited in the marked red. So we have marked the images as red. From 0 to 2 and 0 to 1, the graph is connected. The graph is connected like 0, 1, 0, 2. So we are going to find the shortest distance between this. From among these two nodes, we can able to tell that 0 to 1 is the shortest distance. So next step, check for the adjacent nodes. So the next we have already told that 0 to 1 is the shortest node. From the next step, we are going to mark as 1 as a visited node, because we have checked for the adjacent nodes. Now we have the choices, either 1 or node 1 with distance 2, or choose node 2 with distance 6. So the main algorithm of this Dijkstra is to find the shortest path. So we are going to find the shortest one with the node 1 with the minimum distance of 2. So it is marked as the second node. So first node is node 0 and next node is node 1, which is the weighted value of 2. In next step 3, we are going to move forward for next, which is we have marked the one as a visited node in before step. So we have to take this next path as from node 1. Then move forward and check for adjacent node, which is node 3. So we have completed already 0, 1. Next, the shortest path, the next node is 0 to 3. So we are marked as a visiting node and are calculating the distance. We have got 5 plus 2, which is equal to 7. From 0 to 1 and from 0 to 1, 0 to 2 and 0 to 1, we have the shortest distance of 2 and 6. We have selected this 0 to 1 as the shortest distance, and from next visiting node it will be 1. Next from 1 we are going to choose the connected distance, which is 3, which have the weighted graph of 5. So we are going to add those visited nodes of the weighted values 2 plus 5, which is equal to 7, which is the distance of shortest path. And in the next step, we are going to mark the visited node as 3, and we have to, from 3 we have to choose what is the shortest path between the connected nodes, as which is 4 and 5. Same as the step 3, which steps we have visited, it will be marked as a visited node. Now two choices for adjacent node, because either we can choose node 4 with distance 10 or node 5 with distance 15. So it is the shortest path algorithm. So we are going to take the shortest path, which is from minimum 3 to 4 with the weighted graph of 10. So it is now visited as a marked node. So first we traveled from 0, which in step 1 we traveled in 0. From 0 to connected nodes we chosen the shortest path, and shortest path is marked as the visited node 1, and from 1 we have chosen the which is the shortest path, and from it it will be marked as 3, which is the weighted graph of 5, and we need to add the two nodes of the weighted value, which is 7, and from 3 we have to taken to the shortest path, which is 4 with a weighted value of 10. So it will be marked as the visited node for step 4. And then we need to add for which is the shortest path. From 0 to 1 it is 2, 1 to 3 it is 5, then 3 to 4 it is 10. So we have to add the weighted graphs of 5 plus 2 plus 10, which is equal to 17. And in next fifth step, we are going to move forward and check for adjacent node, which is 6. So first step we have completed from 0 to 1, and then 1 to 3, 3 to 4. Then from node 4 we are going to check which is the next one. So we have node 6. So it is marked as the visited node with a weighted distance of 2, which will be again added from the node 0 to node 4. That will be 2 plus 5 plus 10 plus 2, which is equal to 19. So this is the simplest path algorithm where we can able to find it which is the shortest path. So that will be easier to calculate where we can able to describe the path algorithms. So here will be the unvisited nodes which where we can will not be visited, that is tends to 2 0 1 2 3 4 5 6. That will be your unvisited nodes because we are starting from with 0. Here we have the distance of 0 to 0 and 1 to 2, 1 to 2, 2 to 6, 3 to 7, 4 to 17. So we have these values will be the counting values of 2 plus 5 plus 7, 10 equal to 17. So we have visited the nodes. Again move forward and check for adjacent node which is node 6. So mark it as visited and add up the distance and the overall value will be added which is tends to 19. The overall weighted graph values will be added as 2 plus 5 plus 10 2 plus 5 plus 10 plus 2 which is equal to 19. Then the mark node 6 will be as a visited node and then add the distance that the value of 19. Node 0 value tends to 2, node 1 value tends to 5, node 3 value tends to 10 and node 4 value tends to 2 which is 19 value. Then this is the applications of Dijkstra's algorithm where first application tends to digital mapping services in Google Maps. For example, we are going to certain place, we need to find the place which is the shortest path. In Google Maps it will be in various route that it will shows longer route or else in shortest path. In that system we are which obviously we will choose the shortest path only because it will be able to travel easily. Like that only Dijkstra's algorithm is able to digital mapping services in Google Maps is the shortest path where we can able to travel from cities. And next is the telephone network where we will able to find the shortest signals or else network coverages where it can be able to connect it as much. Then social networking applications is one of the Dijkstra's algorithm. This is the previous year GATE questions. Suppose we define a different kind of graph where we have weights on the vertices and do not the edges. Does the shortest path problem make sense for this kind of graph? If so, give a precise and formal description of the problem. If not, explain it. Note where we are not asking for an algorithm, just what the problem is or that it makes no sense. This problem makes a sense because it has a starting vertex of value vertex with V, and this Dijkstra algorithm has a certain formula where G equal to E comma edges comma vertex. So it gives the sense because it has a starting vertex V with the low cost path from V to every other vertex. For example, we can see in this slide because it has a vertex with the shortest path with the shortest edges values, and then it tends to biggest value. Like that, we are going to solve this question giving a starting vertex V with the lowest cost path from vertex V to other vertex. The cost of the path is the sum of the weights of the vertex on the path. The cost of the path means it is the weighted graph. It is the weight, sum of the weight means we are going to add the nodes value, that is directed weighted graph, node 0, 1, 2, 3, like that. 2, 5, 10, those we have values added, that will be the shortest path. Thank you, and continuing will be in next class.